Okay, lesson 4. We are working on this lesson here. It's very easy to study this lesson and predict what's going to happen for your unit test, because this question, it's always on every single unit test I've ever seen on 20-1. What you're going to see is basically one of the best uses of this form. So you could read those steps if you like. I'll just do the steps and you'll see how it works. Got some interference next to my phone, sorry. When you're given, when you're given the vertex, you get most of the equation. What's the only thing you don't have? No, you always have to have y and x. Y and x are always there so that you can have an equation, because like y depends on x, right? Independent, dependent variable. So if they give you the vertex, and that's what that red blood says, P and Q are given. What's the only other thing you don't know? A. So basically this question is like unknown A question. It's very easy to predict. You could practice it a few times and you get it mastered. This is just basically the unknown A question. That's what I would call it. Unknown A. Okay, so let's take a look. What do they give us? Please don't talk back there. Thank you. What do they give us? Okay, good. So underneath the vertex, well, what's happening? Underneath the vertex, put a P, comma, Q. Good. So you agree that P is negative and Q is positive? So when we go to put it in the equation will have a -2 or a +2 in the equation? It'll say +2, good. Because it'll say x minus -2, which is +2. And then where it says plus q, you're going to put +8. Okay, so let's do that now. Y equals a. And this is a step probably all of you can skip, but I'm going to do it. X minus -2. And a lot of you can skip that step because you're smart people. And you get this. A x plus 2 squared plus 8. Agreed? And that secondary step, if you're quick and bright and you remember it, you don't have to write it. Okay, and then somebody said something about this point. What is this? A coordinates. So the first one is x and the second one is y. So now we can go ahead and put those in. So it says 7 equals a -1 plus 2 squared plus 8. And what's the only unknown? And is this easy? This is so easy. And it's going to be on your test. Let me look at the test right now. Pause this video. All right. Okay, how do we solve this? And is there any simplifying we can do? Don't lie to me. What's in that bracket? -1 plus 2 is? What's 1 squared? What's 1a? Just a. What's a? Very nice. So then you rewrite it because now you have the equation. So we have back up to where we had the equation except for the a. We have, I can just put a negative there, x plus 2 squared plus 8. Now we can graph it. Well, we can graph some key points, right? So where's the vertex going to be? -2 and then down at, what was it, +8? So 5, 6, 7, 8, and here. Agreed? So there's the vertex, -2, 8. They gave us another point. Do you agree? is it negative 1 comma 7? So negative 1 comma 7. Is that here? Is that right? Can you use some symmetry to get another point at 7? Or when y is 7? You can use symmetry to get this spot. Do you agree? Negative 3 comma 7. I got this one from symmetry. Has to be a mirror image across the line down the middle of the vertex. Agreed? What do they call that line again? What is this line again? Good. Line of symmetry, or axis of symmetry, which cuts through the x value of the vertex. Okay. What else do we know? Do we know a y-intercept? And what does this a value that's negative tell me? This right here. It opens up or down? Are you looking up at God, or are you looking down at that guy down there? Looking down. Who's down there? Satan? The devil. And you can see, yeah, it's going down. Like it's going to start like this. The only thing we don't know the y-intercept, do we? So if we go down to the next part of the question, this is going to happen quite a bit on your test. I was just looking at the multiple choice. Going back and forth, okay? So how can we take our equation that we have in the vertex form and then put it in this what they're calling the general form? You can't distribute a into the brackets yet. You have to expand the brackets because exponents go before multiplication in the bedmass order. So you have y equals negative x plus 2, x plus 2, plus 8. It's a perfect square, so you get 4x and 4. Now I can distribute the negative. And if you don't believe me on that perfect square, you can FOIL it out to double check. However, you need to get super good at perfect squares because starting tomorrow, you have to be a perfect square master. And I'm not even joking. Okay, distribute the negative. And now we add 8 to the constant. So what do we have there? Negative 4 and a positive 8 makes 4. And what's the constant on the graph? What's the constant again? It's an intercept. Which one? X-intercept or y-intercept? It has to be the y-intercept. It's at 4. So up on our graph at 4, you can put the y-intercept. That was brutal. Okay, so at 4, you can put the y-intercept. Now we can use some symmetry. How many steps over to the vertex? 2. So then you would have 2 more steps that way. So right here, negative 4 comma 4 is another point that I got from symmetry. Negative 4 comma 4. And this is 0 comma 4 from symmetry. Now we're starting to see what this quadratic looks like. What's the next thing that I'm missing on this graph that I could get? Where it hits the x-intercepts. How do you get those x-intercepts? We've been talking about this since the last chapter. Where do we get these from? Good, factoring. I wonder if we could factor this thing at the bottom. Anyways, I'll let that sketch stay up there for a second. You can look at it. And then maybe we could factor this quadratic. What do you guys think about that? I wonder if it's going to be 1 and negative 5. Okay, I'm just going to rewrite it. It was negative x squared, negative 4x, and a positive 4. Was that right? Or positive 4? Okay, so let's factor out a negative, and you get x squared plus 4x minus 4. Can we factor that? I don't think so.
Wait, what's the negative one side and positive two?
Negative 2, but then you get positive 4.
Can't factor this.
Okay, so these x-intercepts will remain a mystery because we can't factor that. So there might be a better strategy coming in a few units later, or in a few lessons later. Okay, so we can't factor it. Okay, let's keep going. Next page. Here's the strategy. Finding intercepts from the standard form. Okay, so we can use the equation in the standard form, and I'm just going to put the vertex form there. Okay, so algebraically determine the x and the y-intercepts. Okay, let's just start with the y-intercept. This is much easier. How to find the y-intercept? What has to be 0? And I'll just draw some intercepts for you. And this, like, if you forget during a test, draw this. This would be 0, comma, y, and this would be x, comma, 0. So if you forget what goes to 0 on a test, just draw a grid like this and plot it. So how do you find an x-intercept? Well, y has to be 0, right? How do you find a y-intercept? Well, x has to be 0. So let's do that one first because it's way easier. Make x 0. When x equals 0, you have y equals 3, negative 1 squared minus 9. And this has to be clear from this point forward. Anytime you square a negative, it becomes, because watch the failure that's about to occur.
Hey, can we like send some like top 10 math fails?
This is not probably number 1 math fail with calculator.
Hey, let's see this.
This is probably the number 1 fail. Why?
Because
This is actually quite a burn. You guys are going to get some lotion after for this burn. You guys ready? The calculator knows BEDMAS, but you don't. Oh! Hey now.
it's gonna go square and then negative, right?
Yeah, what this does is it squares positive 1 and then tacks on the negative. Because the calculator wants to do order of operations properly, right? So if you wanted the calculator to do it for you, you'd have to do this. Make sense? Okay, so don't make that fail. A lot of people, like, they resort to this, which is normal. But at the same time, you got to be thinking, and I've just highlighted the fact that this is a seriously major fail. People do it all the time. Because you go fast, right? You're going fast and you're on a test, you got a lot on your mind. So you might know this, but you resort to the calculator and blah, blah, blah. Okay, so this is 3 times positive 1. And then you get 3 minus 9, which is negative 6. Okay, so when x is 0, y is negative 6. You guys cool on that? And I didn't mean to burn you guys, you know. Yeah, you should switch classes right now. That'd be awesome. Okay, what happens when, when y is 0? What happens then? So then we got to find the x-intercepts, right? Now on a quadratic, how many x-intercepts can you get? Maximum. What's the most you could ever have? Well, no. The most you could ever have is 2. You could also have 1 if it did this. And you could also have 0 if it did this. Okay? So those are the possibilities. 2 x-intercepts, 1 x-intercept, and 0 x-intercepts. Does that make sense? Depending on the PQ value, right? All right. So let's take a look at what would happen algebraically, and that's the key here. Okay, so we got to make the y 0. So that means 0 equals 3x minus 1 squared minus a 9. Okay. This is an equation that looks challenging at first. Where's the unknown? Is it in the bracket? So you have to think of that bracket as like a lock box. You can't get in there until you do what? Till you what? Not square, but what did we do last unit? The radical stuff? The radical stuff, we isolated the radical and then we squared it. So what do you think we should do here? Isolate the bracket and not square it, but square root it. Good. So move the 9 over. And now what? No. Isolate, 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 like you're going to be isolated. Yes. What's in the way right now, Joel? Or pardon me, Joel? Good. So what are you going to do with it? So divide by 3. You get 3 equals x minus 1 squared. Now what? Good, square root it. That's going to unlock. Unlock with square root, okay? So on the left, you have the plus or minus of square root 3. And on the right, you have x minus 1 finally unlocked. Now what's up with the left-hand side? I kind of put on some craziness there. Why is that the reality over here? Why? Go for it.
Because whenever you square a negative,
Good.
it becomes positive. So like you don't know the actual answer, so we're just gonna put it both.
Both, right? It could be negative 3 times negative 3, or it could be positive 3 times positive 3 in the root. All right. Now what do we do to solve for x? Because now that we've unlocked that bracket, you don't need them anymore. Now what do we do? Go throw 1 on the other side. So it's 1 plus or minus root 3. Now, what does that mean? That means one of your x-intercepts is 1 plus root 3, and the other one is 1 minus root 3. And this is your solution. These are called exact values. And you can go to decimal for approximate values if you like. Question?
Will every answer for this unit be like this? These will have plus minus the same value? Or no?
Yeah, so like this question here, you wouldn't be able to factor. But they still have x-intercepts. You can't factor it, but you still have x-intercepts. So you got to use a different strategy. How would you would put this into your y equals, and then when you did the number 2 zeros, it would be the same as if you typed this into the calculator. Yeah. All right. This looks like a multiple choice question. This one here looks almost identical. What did they give you? They gave you a rando point, and they gave you the vertex. So if you ever are given the vertex and a point, then you're going to start with the vertex form. And because we're smart people, we're going to go straight to plus 1 and plus 2 because we're smart people. And we know that if it's 1 left, the equation says plus 1. And if it's 2 up, then it's plus 2. And now we need to solve for the a value, so we're going to sub in our point. We're going to sub this in. So y is 1 and x is -3. Sorry. Now, what's the first thing you guys want to do on this next line? I'll give you guys time to catch up and think. Simplify the bracket. What do you guys think? Should we do that? Yeah, what you could really do here is you can simplify on the inside, and you could probably move the 2 over all in one step. I mean, if you can handle that. So this becomes -1 because I minus 2. And this becomes -2. How about that? Is that crazy? Looks okay. Now we have to square. So what do you get there? And now we can divide by 4, and you get what you're looking for. So then I would just rewrite this bad boy. Got -1/4 the x plus 1 squared and the plus 2. And you have your equation. This is what you could put in your y equals. Do you see a fat quadratic or a skinny? I see fat. Because of the fractional a value. If it was greater than 1, if that a value was greater than 1, if this was a 4, you'd expect quite the skinny little guy. You guys ever hear the story of Fatty and Skinny? Oh, it's an age-old story passed on from one generation to the next. Fatty and Skinny went to bed. Fatty rolled over and Skinny was dead. Craziness, right? All right, next. Find algebraically the x-intercepts and the y-intercepts. And then they want the exact value and the hundredth. So once you get those radicals, put it in your calculator. Do the y-intercept first. That's very easy. When x is 0, what happens? -1/4. 1 squared plus 2. What's 1 squared? 1. So you have -1/4 plus 2. This is easily done on the calculator in 2 seconds. I'll just quickly make this 2 8/4, and you get 7/4. You and your fractions. 2 is 8/4, man. Right? And then 8 minus 1 is 7. You and your fractions. A 2. I'm not spending time on fractions in 20-1. I apologize. If you need a fraction tutorial, then you can talk to me. And I'll help you, but not right now. Okay, next one. X is 0, so now we're going to do y is 0. This is where it gets a little bit more challenging. These are the x-intercepts. Okay, so look up at your equation. We got to make the y 0. So 0 equals -1/4. You got an x plus 1 squared plus a 2. We got to unlock that x. That's the challenge. So we need to embrace our isolation. 2 goes over, and then what? Oh gosh, you want to divide by... You're afraid to add fractions, but now you want to divide by 1/4? Oh my gosh. You guys got it twisted, man. Why would you divide by a quarter? Why wouldn't you just times 4? So times -4 times -4 and okay, 8. Square root it. Good. Now, if this was middle to the end part of September and we were doing the radicals unit, how would you deal with root 8? What would root 8 become? A mixed radical. How does 8 break down? 4 and 2. The 4 comes out as a 2. So you have plus or minus 2 root 2 equals x plus 1. Yes. And then finally you get plus or minus 2 root 2 minus 1 equals x. So now you can go and finish it off. x1 is positive 2 root 2 minus 1, and x2 is negative 2 root 2 minus 1. And then you just pop it into your calc, which I don't have. Of course I got one. So we'll go negative 2 square root 2 minus 1. It said nearest hundred, so 3.83. And then the positive one is 1.83. Well, like a true math person would say they only want the exact value. And then this would be like if you had to input it into a numerical response, like for a standardized test. Any questions? What's up, Carl? Remember, Carl, there's no stupid questions. Fred, you want to share that with the rest of us? Come on, Fred, we're like a tight little family here. No questions so far? You know, it's okay. Okay, so domain. Domain, do you guys recall what domain is? All the possible x values for a quadratic is going to always be the same answer. Yeah, you guys can really cheat your way through this one. You don't even have to think about it. It's always going to be x real. Unless they do something really specific where they restrict the domain. But you'll always have that, x element real. So I'll zoom in so you can look at it. That's just the way I write the R. I put like an extra bar. It's just like a script R. Like, you know, when like those losers get the tattoos and it's like, kidding. You got one of those tattoos? I'm one of those guys. So it's just an extra R, so or an extra bar for the range, or the real. So not get it confused with range. Okay, because you'd write this. You'd write domain, and then when I go to write the range, I'll use R again. So I don't want to get it like confused with that R. Okay, so what's the range going to be? You have two options always for the range. It'll always be y less or equal a max or y greater equal a min. That's always going to be the case. So which one here? Are we looking up at God? Or are we looking down at Satan? Which way are we looking? We're looking down at Satan. Satan's down here. And God's up here. Which way are we looking? Down? So then this guy's a max. That guy's a max. So that means all other y values are below it. So if everything's below a certain number, then we have to choose this one. And what is the max value? It's the y value of the vertex. It's 2? Okay, thanks. Y less or equal 2, comma, y element real. That would be what you want there. What's the next one? Equation of the axis of symmetry. That one's very easy as well. You just go x equals some constant. And which value is it going to be? X equals some constant. What's it going to be? Because the line of symmetry would cut right down the middle like this. Which line does it cut down? 2, 1, 3, pi. Well, you're just guessing. So this would be x equals -1. Vertical lines are always x equals some constant. In our case, it's -1. This is what you want there. X equals -1. Any questions? Okay, well then get to work. I would say 1 is critical. 2 is a repeat of that. So 1 and 2 very similar. Make sure you do number 1. And then 4 is awesome. And I really like 3 because you're going to get those characteristics in there. So let's go 1 to 4, and if you really want to skip 2, then fine. But 1 to 4 is critical, and then if you can get past that, then that's amazing, and I really, really want you to try that. But for those that are doing the bare minimum, 1 to 4, omit 3, or omit 2. But if you really want to do well, do it all.